Hi, welcome to this talk on how to build observability into a serverless application. I thought I would start by just explaining what do I mean when I think about observability and how is it different to monitoring. So monitoring to me means watching out for things like failure modes that you already know about, such as network I/O spiking or CPU spiking, or potentially you're using up too much memory. It's the kind of thing that lends itself really well to being shown on dashboards and monitors and having them put into the offices whenever we all return to our offices. Whereas with observability is, I guess, closer to maybe some of the government agencies are doing in terms of collecting metadata about the communication that's happening inside inside the community, so that they can then gain insights into the system's behavior by only observing it from far away, hence the name observability, and so that they can ask arbitrary questions of the data, questions that they may not know they need to ask when they were collecting the data. Whereas with monitoring, you kind of have to know what you're looking for before you start collecting data. And in control theory, observability is a measure of how well the internal state of a system can be inferred from the knowledge of its external outputs. So this is the important bit here. What are some of these external outputs can include things like your logs, your metrics, or traces that you are publishing from your application. And if you go back to probably one of the first articles on observability, the whole idea of it, in terms of the actual implementation, the general consensus is still moving around, but you tend to think about having to have monitoring, alerting, visualization, tracing, and some kind of log aggregation so that you can easily search through all of your logs. And as the systems that we are building become more and more complex, it also becomes much more difficult for us to actually figure out what actually went wrong when something happens in production. And so we need more help in terms of figuring out what's actually going on in the system and alerting us when something is happening. Luckily for us, as we're building these more and more complex systems and our needs grow, so did the software and other SaaS platforms that we can use. They also got better, and they can do much more for us in terms of helping us gain insights into the running of our applications. So the tools in the microservices space for containers and for EC2 instances, for VMs, it generally has become quite good, and they are getting better all the time. And then, of course, came 2014. Amazon kind of threw a whole curveball into the mix, and they announced the Lambda, and it became an arrow to the Achilles heel to a lot of these existing tools, because many of these tools expect what they need to have some kind of an agent or daemon running on the server in order for them to work as intended. And of course, with Lambda, there's just nowhere you can install those agents, which has made it really difficult for some of these systems to work. So my name is Yan Cui. I'm an AWS Serverless hero, and I've been using AWS to run production workloads at scale for many, many years now. And in the last couple of years, I've focused primarily with building systems using serverless technologies, including moving a social network to run pretty much entirely on serverless, which you can read all about in that link here. Nowadays, I spend half my time working with Lumigo as the developer advocate, and Lumigo is a troubleshooting platform for serverless applications. Think of it as like one central place where you can find all of your logs, traces, and all of them together, and have nice visualization to see what's actually happening in your application, so they can see the traces alongside the logs side by side. And the other half of my time I spend as an independent consultant, where I work with different companies all around the world in different industries to help them move faster by adopting serverless technologies the right way, and to also help them troubleshoot any problems in the architecture by providing and also giving them training to upskill their engineers and give them advice and consulting to help them make sure that they're following the best practices for AWS and for serverless applications as well. And occasionally I work with clients to help them deliver features and products quickly. In my spare time, I also like to produce a lot of content in terms of blog posts, video courses, and I've got a new book that I've been working on with Peter Sparsky from MacLeod Guru and AJ Nair, who is the program manager for the Lambda team. And right now, our book, Service Architectures on AWS, second edition, is in the Manning's Early Access program. And besides that, I also run a bunch of workshops all around the world, and including one in Helsinki coming up in the next couple of months, which unfortunately has to be postponed due to the current lockdown. And I also have a 4-week virtual workshop, which I just announced as well. So please go to this link and check it out. And if you stay until the end, I also have some discount codes for you guys as well. So moving on. So with serverless, one of the things you find is that we face a bunch of new challenges that we didn't have to consider with previous, generation of tools that we use. One of the first ones that comes straight to mind straight away is the fact that you now don't have access to the underlying operating system, which is great from many perspectives in terms of security, but also in terms of maintenance overhead. But it also at the same time means that there's nowhere for us to install those monitoring agents and daemons, which has played a crucial job up to now in that they are able to do their job outside of the critical path where we really care about minimizing any user-facing latencies. So all these agents and daemons, they'll be running in the background, collecting logs and metrics and so on asynchronously, so that they don't add overhead to your user request handling code in your web API. And then they're able to batch them and send them to the backend services such as Graphite or whatever it is that you're using to aggregate and collect your data, your monitoring data. And with platforms like Lambda, you just lose the ability to do background processing as a whole, besides the few things that the platform does for you, which we're going to talk about in a minute. So that's quite a big shift in terms of tooling, the fact that we don't have background processing anymore. And another important change that's happened is that before, when we're building our web application, running them on EC2, concurrency is largely handled by our own code. And we have to consider, for the tools that we use for monitoring and so on, how much CPU overhead they have on our server, which has impact on the maximum amount of concurrent user requests we can actually handle in our application. Now, concurrency has been largely shifted and lifted up into the platform. So if you've got multiple HTTP requests coming in, Lambda platform would make sure that you have one container handling one request at a time, but it handles the concurrency for you, which is great in that it drastically simplifies my application code. But one of the things we do lose in terms of the monitoring side of things, we lose this economy of scale, whereas before our agents can collect logs and the metrics and batch them at the EC2 instance level, which can cover many concurrent requests that's happened on the server. And now the best we can hope for is for them to be batched in individual concurrent executions at the Lambda invocation level, which means that in terms of the traffic we need to send to our observability system, now instead of having one EC2 server sending large batches at a time, we now have many smaller containers that are going to send traffic to the backend monitoring system, which also means those systems need to be able to handle much higher concurrency in terms of how much data is ingesting from our application. And I don't know about you, I guess we all have different mileage, but I've worked with some monitoring systems in the past which struggle to handle traffic beyond a certain point, in which case you need to do some intermediate aggregation yourself, and this is going to become more of a prominent issue as these systems have to support Lambda, where you're going to have a lot more concurrent streams of input coming into their system. But you might say, well, that's an easy problem to solve, right? You just use a bigger batch on the individual container level. Well, unfortunately, it doesn't quite work because you see, when traffic goes up, the Lambda service is going to create new containers to run your application code, your function. And the first invocation on that new container is going to be what we call a cold start, where it takes a bit longer because you have to initialize your function modules, your dependencies, and all of that. And if you say you are batching those monitoring data for logs and metrics in between invocations, and then when traffic goes away, Lambda, some of this container is going to become idle, and the Lambda is going to garbage collect any container that's been idle for, say, 5 to 10 minutes. That's the average we see, which means any data that's sitting on those containers and haven't been flushed is going to get garbage collected along the way as well, which means you have a higher chance of losing data if you are not sending them at the end of every invocation. So you say, okay, that's fine. In that case, so let's just send it at the end of every invocation. It's going to have more traffic to the backend system, sure, but if we're just using a vendor that can support a higher load, then there's no problem, right? There's also something else you got to think about now as well, because everything you're doing in your function has to be done inside the function's execution. That means any background data processing that you're doing to send metrics and logs to your monitoring system, they will have to be done as part of the same invocation where you're performing those business logic to handle a user request, and which means that your invocation time is going to be longer, because remember, we don't have background processing anymore. And if you're building, say, APIs using API gateway and Lambda, whereby until your Lambda function actually completes all the execution, and then response gets sent back to API gateway, because when API gateway invokes a Lambda function, it's strictly a request response. Until the whole function is finished executing, then it doesn't get the response back, which means in terms of the end-to-end latency, now you're going to add extra time to that latency. And so there's more, so it means your user potentially have to wait for longer for some response to come back. So now you're kind of stuck in between a rock and a hard place, whereby you are vulnerable to data loss if you're batching and sending those data. But if you're sending them regularly at the end of, sending them eagerly at the end of every invocation, then you're adding latency to your user-facing systems. We are going to talk about some workarounds later, but those also come with their own trade-offs as well. Another thing we see is that there's this rise of event-driven architectures with serverless, mostly because I think with Lambda, Kinesis, and EventBridge and all these different systems, it becomes really easy for you now to build a truly event-driven system with lots of compute happening and reacting to events that's happening in the system. So what we see now is that there's a lot of functions being trained together through synchronous invocations, through things like IoT messages, files being dropped into S3, or more likely in this case between different functions. One function will publish a message into a SNS topic or to an EventBridge event bus, and that triggers another function to pick up the job and then do something else, and then so on and so forth. And of course, tracing asynchronous invocations is a lot harder compared to tracing those synchronous invocations through an API call. Because with HTTP and API calls, so we know how to trace them by just passing the trace ID through the headers. So those are some of the challenges that we face in terms of the tooling side of things. How do we support service applications so that you can really gain you can really easily debug a problem that's happening in this very complex system with lots of different ways that functions can be triggered to do something. But still, it is still possible to make your service applications observable and easy to debug. And I'll argue that it's oftentimes much easier to get there, at least to a reasonable degree, because a lot of building blocks comes out of the box, at least when you're using a managed platform such as Lambda. Take logging, for example. Anything that you write to your functions, the standard out, will be captured by the Lambda service and shipped to CloudWatch logs. And it's going to include additional information such as a UTC timestamp, as well as a unique request ID for that invocation. For that request. And when there are retries for failed asynchronous invocations, you will see the same request ID for those retries as well. So that's another way for you to train. So I guess to group retries with the original invocation. So that's good. You don't need to manage any infrastructure pieces, any sort of run any agents on your containers, so on, just to do basic log collection at scale. And then any logs from your function will be sent for the same function will be sent to its own log group, within which you have many log streams, and there's a one-to-one mapping between, say, a container that's running your application, your function code, to a log stream, so that you can kind of use this to approximate how many concurrent executions you have around the same time. But nowadays you don't need to do that anymore, because they now publish the concurrent executions metric for every single function you have, and not just the functions that you enable reserve concurrency on. So the problem with CloudWatch logs is that it doesn't make searching your logs very easy. They have made the strides in this particular regard with CloudWatch logs insights, but I'll still argue that it's a lot more work and not as scalable and flexible compared to my Elk stack. With CloudWatch Logs Insights, for example, there's a whole different search syntax, which is kind of somewhat unfamiliar, at least for people that's coming from Elk. And also, you are limited to only to be able to search 20 log groups at a time. So in the cases where you just have an error message, you have no idea where it's coming from, it's not particularly useful, because now you have to figure out, okay, which 20 log groups do I search at a time, rather than just say, hey, Elk, here's some string, please find me everything that matches this, so that I can start to narrow down where the problem is actually happening. So what most people do is they will go to their log group, they will say actions, and then they will stream the logs to either a hosted Amazon Elasticsearch service, but more often I see people streaming them to a Lambda function, and from there they can then send those logs to whatever log aggregation service they want to use, or be it Logs.io, some self-hosted Elk stack, Logly, Log Entry, Splunk, whatever. No, that's entirely up to you where you send those logs to. One thing to keep in mind here is that while this configuration, this setup is straightforward and is really easy and to get started with, at least, CloudWatch Logs itself, when it triggers a Lambda function, is also considered as the async event source, which means if you've got a lot of business functions that are serving user requests from APIs, writing logs, then that's going to trigger a lot of your log shipping function as well. So in this case, if you are using a certain amount of your regional concurrency on handling those API calls to add the business value to your application, and those logs that they're producing can also trigger even more Lambda functions to process and ship those logs to somewhere else as well. And this might push you a lot closer to your regional concurrency limit if you're doing your projection based on how many API calls you receive per second and so on. So you might be a lot closer to your regional concurrency limit, which by default is 1,000 for most regions. It's a soft limit, you can always just raise it, but just in terms of your planning and the projections of your concurrency needs, this is something that you should keep in mind. And not to mention that it's possible that when you use so much concurrency to ship logs, you can start to cause other functions to be throttled, because once you hit that regional limit, invocation is going to get throttled, and there's no control over which function gets throttled in that case. So your low priority functions that are shipping logs can actually cause your high priority business logic functions to get throttled, which is something that happened to us when I was working at The Zone, where we were doing a lot of very high volume systems. So of course that wouldn't be great. So, and in this case, what you could do is you can either set the concurrency limit by enabling reserve concurrency on your log shipping function, but now you've got this potential case of losing logs because that function is going to get throttled constantly when it's under load, so that the same event can get retried multiple times, well, 2 times, and then still fails, and then it's going to get dropped into a dedicated queue instead. Or a much better way to do this when you're at scale is use Kinesis first, so that you configure CloudWatch logs to ship your logs to a Kinesis stream and have that trigger a Lambda function to then forward those logs onto the destination. The reason why this is a much better approach is because between Kinesis and the Lambda function, you can precisely control the amount of concurrency for the Lambda function with the number of shards you have in the stream. By default, there's a one-to-one mapping here. And recently they did introduce this ability for you to configure the concurrency within one shard, so you can have up to 10 concurrent Lambda executions to process events from the same shard, so that you can increase the throughput by having more concurrency if you're finding yourself falling behind in the stream. However, you still have that precise control of how many concurrent executions you have based on that configuration and the number of shards you have in the stream. Another thing to consider is that every time you create a new Lambda function, it's also going to create a new log group as well. And you don't want to have a manual process for someone to have to go into the CloudWatch Logs console, click on the log group, and then click actions and subscribe every time they create a new function. It's just something that people are going to forget. What you could do in this case is first enable CloudTrail so that you can then capture any API calls against the AWS services on your behalf, including whenever a new Lambda function is created, a system is going to call the cloud create log groups, the create log group API call against CloudWatch Logs, and you can put an event pattern in EventBridge or in CloudWatch events to then say, okay, whenever that happens, please. So whenever this event gets matched, please call a Lambda function. In this case, we have a function called subscribe log group to then subscribe this newly created log group to the Lambda function or to the Kinesis stream that we use to ship our logs to either Elk-Stack or to whatever. So since this is quite a repeatable pattern, I actually publish an application to the Serverless application repository so that you can easily deploy them to your AWS environment by just clicking this button, or you can deploy them through CloudFormation, through SAM, or the Serverless framework. And what this SAR app is going to do is every time you create a new log group for whatever reason, you will automatically run and subscribe that log group to the ARN you gave it, which could be a Lambda function, it could be a Kinesis stream, or a Firehose, whatever it is that you choose, or even Amazon Elasticsearch as well. And when you first deploy this SAR app, it also goes through all the existing logs and then subscribe them to your ARN as well, so that you don't have to have a separate job to subscribe existing stuff that you already have in your environment. And equally, by default, when you create a new log group, it's set to never expire your logs, and that's because Amazon doesn't want to delete your data without you explicitly tell them to, which is great. However, when you're shipping your logs somewhere else already and you are paying for processing and data storage for that new service, it doesn't really make sense for you to be paying the same for them in CloudWatch Logs as well, which is have a charge of, I think, about 3 cents per gigabyte per month. So if you never expire any data, then that cost, the monthly cost, is going to keep building up. So I've got another SAR application which, when you deploy to your account, would manage and automatically update the retention policy for those log groups to the number of days that you specify. In terms of monitoring, monitoring and making your application observable, one of the most important things you can do is to just write structured logs with JSON rather than just just a log message with no context about where is how it's happening. And this is something that we've actually learned to do in the past already when we're building microservices, and there's some really good articles out there on how to do it well and some of the things you should consider. So rather than just saying, okay, we are calling API B, I would instead write a JSON blob that contains the actual the message I want to log, but also context around that whole operation. For example, correlation IDs, the user agent for the request that came in, and any information about the actual endpoint that we're calling, and so on. So this makes it a lot easier for you to find the relevant log messages. For example, when you've got lots of things happening across different APIs, and in a microservices transaction, then correlation IDs can be used to help you find related log messages across different systems. One thing I do find though is that a lot of traditional loggers you find for .NET or for Node.js or for normal applications, it's just too heavy. They do all kind of things for managing rolling files and all of that stuff, which we just don't need for Lambda, because again, anything we write to send it out just gets captured automatically, right? So I tend to just have a very thin layer of abstraction on top of the console log, console.log, and then I also wrote a couple of whole suite of libraries, and I published them when I was as an open source project when I was working for the Zone, including a very simple logger that internally just calls console.log with JSON instead. But one of the things it does is it allows you to configure the current log level dynamically by using the environment variables. So you can say for production, only log anything that is warning or error above, whereas in the dev environments, log absolutely everything, including those debug log messages. But we can actually change this dynamically at runtime so that we can make it easy for it to support sampling debug logs, which we're going to talk about in a minute in production. So in this case, we are writing our logs in the JSON format, which makes them really easy to interpret by machines, so that when we send them to an L stack or using an L-like service like logs.io, it becomes really easy for us to filter on different attributes of that message. The one downside of doing structured logging is that now you're writing a lot more data to CloudWatch logs, and as I mentioned before, there's a cost associated with generating lots of logs, and while they may not seem very much, 50 cents per gigabyte of data ingested and 3 cents per gigabyte of data storage per month, but when you consider that for 50 cents, you can actually have a million invocations for 128 meg Lambda function that runs for less than 100 milliseconds. So that comparatively, that's actually quite expensive compared to the compute unit, the compute cost you have for Lambda. And if you log everything in production, then it's quite common for you to spend many times your Lambda invocation cost on CloudWatch logs. In fact, I've seen many customers spend 10 times of the Lambda cost on CloudWatch logs. So a painful lesson that you don't want to learn the hard way is don't log a debug level in production. That said, when something does happen, you also want to have some debug logs that can tell you what happened on those error paths. So many times it's happened that, okay, something's happening in production, I know I've got a debug or trace logs around that, which if I have them, I can figure out what the problem is really quickly. But since we're in production, we only log error messages, so I don't have that. And so now I end up having to go back to the application, quickly modify them to enable debug logging, redeploy, wait for a bit to gather enough debug logs so that I can actually figure out what the problem is, and then I fix the problem, disable debug logging again, and redeploy. And now, if you've got one function, that's one thing, or one project that you have, then that's one project you have to redeploy. But in many, real world environments, you're going to have lots of different functions that are connected to each other through asynchronous event sources or through API calls. And to get the whole picture, to get debug logs for everything, you have to also then do the same thing for all these different services, which is just going to be really painful and slow, and it's going to add a lot of time to your time to resolution of any problem that you're currently experiencing in production. So between the two extremes of having no debug logs and therefore having low observability of your system, to having all of your debug logs and therefore accumulating a lot of logs and costs as well, you can actually just sample a percentage of your invocations and get those debug logs for just those invocations. And the industry standards or convention is about 1% of your requests you'll be sampling debug logs for. And one way you can do this very easily is by using middlewares. And for Node.js applications, that is the middleware engine called MIDI. And what you could do is with our logger, you can, before the invocation, you can change the log level to debug by just modifying the environment variable. And then after the invocation is finished, when the function handler has come back, you restore the log level to what it was previously. So in this case, you can just turn on debug logging for 1% of the invocations. And this is possible. We can modify environment variables safely because, again, concurrency is managed by the platform. So our Lambda functions, every invocation only handles one request at a time. So there's no concurrent HTTP requests that we are handling inside the same container. So we can safely modify the environment variables without worrying about what that's going to do to other concurrent requests we are handling inside the same container. So if you look at the code that we have for that middleware, which is already included in the zone Lambda power tools I showed you earlier, is before the function starts, we're going to check, should we enable debug logging, which in this case does a bunch of different things, including looking at the sampling rate you have, but also looking at the correlation IDs. If we say, okay, we want to enable debug logging for the whole transaction, and that decision gets propagated along as correlation ID, and if we say, okay, we should enable debug logging, then we're going to turn it on with a rollback function, so that when your function finishes or when it errors, we would then just roll it back to restore the previous log level. And if your function does error as well on the, in that case, we also log an error message so that we will log the unique request ID, but also the invocation event as part of that log message, so that you can then easily take that invocation event and then replay your function code locally using things like the Serverless framework or SAM, which allows you to invoke functions locally and give it a payload. So that's that bit there. So I mentioned that you also, if you're sampling debug logs for distributed transaction across many different functions, you also want to make sure that you get debug logs for everything, as opposed to debug log for one function, for one transaction, debug logs for another function, in another transaction. So you never get a full picture for what happened on one transaction as it spans across multiple functions and multiple microservices. So we need to have some way to trace, to send those correlation IDs across both synchronous as well as asynchronous invocations. And also we want to be able to allow you, the user, the application developer, to then also record other useful IDs that you want to be able to correlate your logs around, such as user ID, if you want to see everything a particular user has done over, say, a period of time, or you want to narrow it down to a particular session or a particular order or whatever it is. We want to support different ways for you to be able to correlate your logs together. And again, the only way we're able to do this easily is by storing correlation IDs in the global variable, which in this case is possible thanks to the fact that there's no concurrent requests being handled inside the same Lambda invocation. So rather than you modifying the global variables in a particular format, we actually have a little module that allows you to sort of encapsulate all of that for you, so that you can then easily set correlation IDs, also set your own IDs, your own like user IDs and stuff like that you want to be able to correlate logs on or around. And then so we also have a middleware that's make it easy for you to automatically extract those correlation IDs when your function is invoked. It includes them in the global variable, so that every time you log anything with our logger, always gets included automatically. And this again is using the middleware, whereby before we invoke your function handler code, we will inspect the invocation event and see, okay, is this an API gateway event? It is an SNS event. If so, we know where to look for correlation IDs in HTTP. We will look for them in the headers. For SNS messages, we look for them in the message attributes, and then we extract them, make it available in the correlation IDs module, so that the logger, every time you log anything, will include them automatically without you having to consciously make the effort to do that every single time. And of course, we got other things as well that allows you to send those correlation IDs outwards to other API calls, other services. And right now, our tools support a whole range of different services from ALB, API Gateway, DynamDB streams, Kinesis streams, Firehose streams, SNS, SQS, event bridge, step functions, as well as direct Lambda invocations. So most of the services that we use, or at least most people use on a daily basis. And as I mentioned, the logger will automatically include those captured correlation IDs, so you don't have to remember to do this yourself. And when you're using our SDK wrappers for AWS SDK clients, as well as the HTTP module, then those correlation IDs get forwarded on automatically as well. So to walk through a simple example, HTTP request comes in. If the client doesn't pass in any correlation IDs, then we're going to initialize it using the in this case we actually use the, when it comes from API gateway, we actually use the API gateway request ID to initialize the correlation IDs with, and whenever you send out an HTTP message, we include those as correlation IDs in the header, so that the function on the other end will see that, inspect that, and then extract the same correlation ID, and you will use it for all of its logs. And again, all of this is possible because we can safely use the global variables within one invocation, because there's no concurrent request being handled inside a Lambda invocation. So you can see in this case we have the correlation IDs there, as well as other correlation IDs that we've included in our application. They are always included in the outbound request that we send as well. So if you're using Node.js, please go. So if you're writing Lambda functions with Node.js, then please check out this suite of tools. It's a whole suite of very tightly integrated tools that does a lot of things for you, including supporting sampling debug logs, making sure that is respected across the entire code chain, not just the one invocation, auto capturing correlation IDs and forwarding them on, and also a very lightweight logger that automatically includes any correlation IDs that's been passed along as well. Moving on to monitoring with Lambda, you get a whole bunch of different metrics out of the box by default, and they're also adding new ones as well. Like recently, they are now include concurrent executions as a default metric that you get for all of your functions. But besides this basic telemetry about your Lambda functions, you also want to record business or application level metrics as well, such as number of orders that's been processed and so on. And normally, this kind of custom metrics would be recorded in the batch in the background and then sent out to the monitoring system. But unfortunately, again, we don't have background processing, and we don't want to add latency to these user-facing systems like APIs. Because even though you may say, okay, even if I make a call to CloudWatch to record a custom metric, it's only going to add about 10, 20 milliseconds for doing that, which is not a huge amount. However, when you consider that you have microservices, that often API is going to call other APIs. So this 10, 20 milliseconds of the extra time that you spend on sending custom metrics can compound. And Amazon actually found a couple of years ago that every 100 milliseconds of latency you add to the user-facing processes can actually end up costing them about 1% in revenue, which again, it's not something that you want to, adding more and more latency. And also when we're talking about 10, 20 milliseconds, we're talking about maybe the 95th or 99th percentile. There's always going to be some outliers as well. So fortunately, before there's all these different workarounds you've got to do yourself, but nowadays, since the last November in 2019, Amazon actually launched this new feature called the embedded metric format, which basically means that when you write to standard out from your Lambda function in a particular format like this, you can actually you're actually telling CloudWatch that to please interpret this and turn this into custom metrics, so that you don't have to have a separate process for interpreting them yourself and then sending them as custom metrics like we used to do before embedded metric format. Now it just comes out of the box. So it's great. It's now taking those it's removing that latency for recording custom metrics from your application. One thing to keep in mind, though, is that there is a cost involved with having lots of metrics. So you're recording all these custom metrics, but you're going to be paying for them. In this case, some maybe 10, 30 cents per metric per month. And how Amazon calculates per metric is also based on the unique each unique combination of dimensions counts as a separate metric. So this means that even though you do want to record many different dimensions, you do want to I guess apply common sense to this. For example, if for some, okay, I heard of one example of one company which ended up creating tens of thousands of metrics a month because they recorded the request ID as a dimension, which means every single request ended up creating a unique combination of dimensions and therefore a unique metric, and that cost them 30 cents per metric per month. So that is a really costly mistake that you do not want to repeat. So use dimensions, but apply common sense so that you don't let your cost for CloudWatch metrics just go out of control. And finally, remember you're paying for alarms as well, which again you do likely to need many of them, as we discuss a bit later as we discuss now. Where when something happens, you want to minimize your mean time to resolution, and a big part of that is just being able to identify those problems as and when they happen quickly, so that you minimize the time to discovery, so that you don't have to wait for your customer to complain before you notice something is wrong. And instead, your monitoring system should alert you through PagerDuty, through through Opsgenie, or whatever it is. So the good question there is that, okay, what alarms should I have? It depends on where it is you're building, but I've got a handful of alarms that I normally would have based on the services that I'm using. For Lambda, I tend to have alarms around the error rate, not error count. So a ratio of errors I'm seeing out of the total number of invocations I see, which you can do using a computing metric in the CloudWatch. And then also for functions, which most of my functions I don't expect them to be throttled, I want to have alarms around those. And for functions that are doing asynchronous data processing through SNS, EventBridge, and then I also want to have an alarm on the DLQ error count as well. Oh, not DLR, DLQ error count, so that I know when Lambda service is not able to push those fail events to a delta queue that I've configured, so that I can quickly fix the problem before I exhaust the max number of retries of that process. And if nowadays, if you're using Lambda destinations, there's a separate metric that tells you when Lambda service is not able to push events to your destination because maybe permissions or whatever, then you also want to have an alarm against those whenever you're using Lambda destinations. For functions that are processing events from a Kinesis or DynamDB stream, you also want to monitor the iterator age, which tells you how long it's been since the event was received in the Kinesis stream. And then so that if this is start to go up, it means that you are falling behind in the stream, so that you want to be able to do something about it, maybe increasing the concurrency per shard to increase your throughput. And then I always have one alarm for the regional concurrent executions metric, which tells me that, okay, I normally set it to about 80% of my current concurrency limit. So if the limit right now is 1,000, then I'll set the alarm at 800. Once I've used 80% of my concurrency limit for say 5 minutes in a row, I get alerted so that I know, okay, it's time to go and ask for a raise, because clearly we are starting to reach that limit that we have. For APIs, if you're using API Gateway, then make sure that you monitor the latency, but only use tail latency number. So P90, 95, 99, whatever makes sense for your application. And also I tend to have an alarm against the success rate. So the number of 2XX responses out of all requests that are handled by API Gateway, so that I know if my SLA is 99% of requests should succeed, then when that drops below 0.99 as in the fraction, then I should be alerted. And I'll maybe have alarms around the specific 4XX or 5XX errors as well, so that I know, okay, one particular error count, HTTP status code is happening very often. And when I'm using SQS, there's also a metric called the approximate age of the oldest message, which I also often monitor as well. Again, it tells me when my processors are falling behind. And for step functions, I don't expect them to fail, get throttled, or timed out, so always have alarms against those. So those are the basic set of alarms that I typically have in my application. And if you're doing I guess a more complex flow where events are handled by one function, published to another queue, that pick up by another function, then essentially you've got this flow rate of messages through a system. And it's also worth just monitoring and alerting on, say, when the flow rate starts to deviate from what you expect, which tells you that part of your pipeline is now falling behind because you expect to see 1-to-1 ratio of messages in and messages out. And if that starts to deviate, then there's a problem that's building up. And most of this can be easily codified and automated, and publish a CloudFormation macro that you can deploy to your environment. And then based on your configuration for your application, it will automatically generate those alarms for you for those standard metrics that we just talked about. And then finally, in terms of tracing, you can use X-Ray, which comes out of the box in AWS. And if you do the work to instrument your application, your code, then you can get a lot of traces, include information about what's actually happening inside your code and how much time is being spent talking to different services. So this is a waterfall chart is very useful for figuring out which part of your invocation was slow. And if you're using the X-Ray SDK to instrument, say, the HTTP client, then you can also you enable tracing in the API gateway and Lambda. Then you can also see what happens behind in the second Lambda function behind API gateway if you are doing API to API calls. And based on the traces information, you can also draw a little diagram of how your system is fitted together. So this is all pretty great. However, X-Ray has got a bunch of different problems, including that it doesn't support async event sources very well. SNS is supported, but not SQS and not Kinesis, not Event Bridge, and many other async invocations just doesn't support active tracing, so that when your transaction flows through them, you don't see them as one transaction, one trace. You see them as two separate things, and you have to somehow link them together yourself. And also, it doesn't span over other non-AWS services, which of course, this being an AWS, X-Ray being an AWS service and all. So this is where services like Lumigo, Epsilon, and Thundra do a much better job in terms of giving you a more complete picture of your transaction by being able to trace through those async event sources, but also when your system talks to other services that are outside of AWS as well. That's everything I've got. Thank you guys very much for listening. And if I want to, in terms of takeaways, the three main takeaways I want you to take from this talk is that you want to write your logs using structured format, and that you should instrument your code so that give you a lot more context about what's actually happening inside your code, and figure out what's actually performance profile your application in the wild. And also, you should build tools that make it easy for everyone to do the right thing, and make it easy for people to adopt. And as I mentioned, I'm working mostly as an independent consultant nowadays, and I'd love to have a chat to see how we might be able to work together and how I can help you accelerate your product and feature development using serverless technology. So if you're interested, please go to the link and see what I can offer. And as I mentioned earlier, I run a bunch of different workshops. So if you want to skill up yourself or your team, then please come and check out some of the workshops I've got, including the ones that I'm running in Helsinki later in the year, as well as the virtual workshop I'm going to be running during May. It's going to be a 4-week online workshop. You probably spend about 4 to 5 hours per week, and you can also get 100 euros off my in-person workshops with this code as well. And the same code can be used to get 20% off my video courses online, which you can of course use and study yourself. With that, thank you very much for your time and attention this evening, and I'm going to be online to answer any questions you guys have, and I hope to see you soon.